Today our topic is surface area of solids. So how can I find the surface area of prisms, pyramids, cylinders, and cones? First off, just some basic vocabulary. Prism, a polyhedron with two congruent faces called bases. So the two bases, and then the other faces are rectangular. So we call those the lateral faces, and those are parallelograms that form the other faces of a prism. Lateral edges are segments that connect the lateral faces. The surface area is the sum of the areas of its faces. So it's just the sum of all the areas of all the faces of a prism. Lateral area would be the sum of the areas of the lateral faces. A net is a two-dimensional representation of a solid. So if you look on the back of your resource sheet, there's some examples of nets given for you, so you can see what nets look like. Pyramid is a polyhedron with one polygon base and then the triangular lateral faces. Vertex is the point where the triangular lateral faces meet. So right up here, you can see there's a square rectangular bottom, base, and then the other faces are triangular. A regular pyramid is regular polygon base. So regular, remember all sides are congruent, all interior angles are congruent, with isosceles triangles for the lateral faces. So that's a key piece, is the isosceles triangles, which means then they have the two sides that are congruent to one another. And then we have the slant height, the height of the lateral face of the regular pyramid. So the slant height and the height are different. I touched on this a little bit in class, but slant height is the height of the triangle face. The regular height is the height of the pyramid from the base to the vertex. So those are two different things. And they will also be indicated differently on your paper. All right, and here's what I was talking about on the back of your resource sheet, just nets. So nets of solids, we have cube, triangular prism, cone, tetrahedron, or a triangular pyramid, square base pyramid, square pyramid. Don't have to have the base in there. You can just say square pyramid. So that can be a resource to you. Also, we have right solids and oblique solids. So right solids are where they're seated upright, they're not slanted. An oblique solid would be where it's slanted. So you can see here, we've got it kind of like the Leaning Tower of Pisa. Kind of looks like it's going to tilt over. Alright, so the meaning of this is surface area. And to start, we're going to talk about surface area of a right prism. Now, there is a formula for this. It's 2 times the area of the base plus the perimeter times the height, which can get a little confusing. It can be a lot of pieces to memorize, and I don't like using the formula. You are more than welcome to use it, figure it out, but I'm not going to be teaching it. How I'm going to teach it is that you're going to draw a net for the figure, and then you're just going to add up all the areas, because that's what surface area is. It's the sum of the area of all the faces. So the first step is we're going to draw a net. So to draw a net, you just break apart the figure. I like to start with the base. So I got the base, the pentagon, the nice regular pentagon. And then there's going to be rectangles drawn off of each side, which I'll draw in color. They're kind of nice, taller rectangles. They do have a height of 9 feet, so, try and make it a little bit accurate. And then off of one of those, you need another base. We need another pentagon coming in here, that regular pentagon. So there's our net. We need to find the area of all of these faces and then add them together. So it breaks into 2 basic pieces. You have the area of the bases plus the area of the faces. So the faces would be the rectangles and the bases would be the pentagons. So let's just start with finding the area of the bases. So we do need to label our net with its dimensions. So we have the 6 feet for the radius, we have the 7.05 for the side length, and then we have 9 feet for the height. So remember, finding the area of the base, it's a regular pentagon, which means our area formula is 1/2 times A times N times S. So we have to take a look at what we know. We know the number of sides is 5. We know the side length is 7.05. We do not know our apothem. We do need to solve for that apothem, which is, remember, the height of that triangle. So we have the triangle 6. We have A. We know that our whole side length is 7.05. So then half of that would be 3.525. So since we know 2 of our side lengths, we can use just the Pythagorean theorem to solve for A. If you use the Pythagorean theorem to solve for A, you're going to get about 4.86. I'm not going to go over using the Pythagorean theorem because I think we should very much well know how to use that. So now we can find the area of one of our bases by multiplying all that together. So if you multiply all that together, you get the area of one of your bases, which is 85.66. So I like to just write that inside one of the figures and circle it, so then I just remember that that's the area. Now we have 2 of those bases, so if we just take this number, multiply it by 2, we get 171.315, which then gives you the area of your 2 bases. Now we just need the area of our faces, which is a lot easier because they're rectangles. So you just have to do base times height. We just have to do 9 times 7.05. And when we do that, we get 63.45. So again, I want to write that inside, circle it, so then I know that each of those rectangles are 63.45. I have 1, 2, 3, 4, 5 rectangles. So I'm going to multiply that by 5. And I'm going to get 317.25. All I have to do is just add those together, and I'm going to get the surface area of this pentagonal prism. So when you add those together, you get 488.57. It does need units, which is feet squared. Area is squared measurements. It's a surface area, so feet squared. All right, we've got our next example, which is surface area of a regular pyramid. Again, there is a formula, area of the base plus half the perimeter times the slant height, which is fine. If you want to follow that, you are more than welcome to figure it out. But again, I'm going to teach using the nets, and I can also tell you on your test, you are going to have to draw nets. So make sure you know how to do that. We are working with a regular hexagonal pyramid. So draw that net. We've got the base, which is a hexagon, and then we just have those triangular faces. So if you draw on those triangular faces, you're good to go. Now I just need to label those measurements. So measurements, we know that the slant height is 14 feet. This would be your slant height, 14. So that's the height of one of these triangles. Then we know that the side length of the hexagon is 10, so that would be the base of those triangles is 10. And then we actually do get our apothem. We get the length of the height of this little triangle here, which is 5 square root 3. So we drew the net. Number 2 is to find the area. So the area is going to be the area of the base. There's just one base plus area of the faces. So in this case, the faces are triangles. So we start off by finding the area of the base. Again, it's a regular hexagon, so it's 1/2 times your apothem times your number of sides times your side length. We know all 3 pieces, which is really nice. We know that our apothem is this piece, 5 square root 3. We know the number of sides, because it's a hexagon, is 6, and we know the side length is 10. Multiply all those together, and we get 259.81. You want to be specific. Is it feet? Yep, feet squared. And then we just have to add on to that the area of the faces. Well, they are triangles, So the area of a triangle is 1/2 times the base times the height. Base is 10. Height is 14. You multiply that and you get 70. So each triangle is 70, to be specific, feet squared. And then there are 6 triangles, so multiply that by 6, and we get 420 feet squared. Add these two together to get the total surface area, and you get 679.81 feet squared. So that is how to find the surface area of a pyramid. Surface area of a right cylinder now. This is actually where we're going to start using those formulas. So the surface area of a right cylinder, I like this formula, 2 pi r squared plus 2 pi r h. So r is radius, h is height, pi, well, that's just lovely pi. So in this case, we're going to find the height of a right cylinder shown, which has a surface area of 157.08 square meters. So surface area formula, 2 pi r squared plus 2 pi r h. We want to solve for height. So we just got to plug in all the other pieces. We know the surface area, 157.08 is equal to 2 pi r. R we know is this, 2.5 meters. So 2.5 squared plus 2 pi times 2.5 times h. And we just have to solve this for h. So first off, we can evaluate this chunk right here, and we can determine that that is 39.25. Write out the rest. Equals 157.08. We want to get h by itself. We are going to need to subtract this 39.25. And this is using 3.14 as pi. When we subtract that, we get 117.83 here, and then we're just left with 2 pi 2.5 times h. Now, you can simplify this. You can just take this piece, but we're multiplying all that together, so we do need to just get rid of it by dividing. But we want to divide by this quantity. So when we type it into our calculator, we are going to have to put it in parentheses because it is a quantity, and these are all being multiplied by each other. So when we type that into the calculator, we would just need to group the denominator in parentheses. When we do that, h is all by itself, and we get that it is 7.51. Dimensions would be meters. And then our last example here is surface area of a right cone, which this we will also use the formula because it's a nice easy formula to work with because it works every time because you're always going to have a circle base. So we have pi r squared plus pi r l. So it's pretty similar to the surface area of a cylinder, but just a little different. So pi r squared plus pi r l. Remember that L is your slant height, not the actual regular height. So make sure you know the difference. Here's a good diagram for slant height. Slant height is the slanted height, whereas the regular height is the straight up and down height. Genius. Surface area of the right cone shown. Let's find that. So surface area is equal to pi r squared plus pi r l. Just need to fill in the pieces. We know the radius is 15. However, we do not know what that slant height is. We do not know what L is. Does make a right triangle, however, so we can use Pythagorean theorem. That's also a Pythagorean triple, so not too much work. We can find that L is 25 yards. So now we know our radius is 15. Our slant height L is 25. Let's just have to plug in the pieces and then use our calculator to do the rest. Type in that. You can actually type in that whole thing to your calculator, and you'll get that it's 1,884 yards squared. Surface area is always dimensions squared, so yards squared. Alright, that's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.